Hi everyone, welcome to day 2 of our lectures. I just wanted to show this reading list again because I did update the reading assignments for this week and then I also added the ones for next week. So I was able to plan out the reading for the rest of the quarter. I'll be revising the syllabus and posting that up, and I'll also send you guys an email of the updated syllabus with our reading assignments. On average, we'll be covering about 2 to 3 sections a day, and after next week I made it to where I'm only going to be uploading on Mondays and Wednesdays typically, so that'll be easier for you guys to watch the videos earlier in the week, get a head start on the homework, and then Friday will be left for if there's questions from Mondays and Wednesdays videos. So we'll go ahead and get started with our lesson for today. Okay, so today we'll be going over sections 1.5 to 1.6. So our first section, 1.5, is equations. So an equation is a statement that two mathematical expressions are equal. So typically these sorts of equations contain variables, but they could also just be, for example, 5 plus 2 equals 7. That's an example of an equation. So we usually have the equal sign, which is the equal sign, so equation. So solving an equation in X, like this, involves determining a value of X that would result in a true statement when substituting into the equation. Now, X is just a random variable. We don't always have to use the variable X. We could use Y, we could use Z, we could use A, B, C, we could use alpha, we could use epsilon, just different, any kind of variable that isn't a number. So the values of X that are substituted into the equation that makes it a true statement, these are called solutions or roots. And when we're solving for our X, we want that variable to stand alone. So here is what a completed equation would look like. We got X by itself, and we know that its solution is X equals 5. So a solution set is a set of all solutions that satisfy the equation. So for example, for X plus 12 equals 0, we we subtract 12 from both sides, and then we get 4x equals negative 12. We divide by 4 to both sides, and then we get x equals negative 3. So our solution set is x equals negative 3. So something to remember here is that operations that you perform on one side, you must also perform to the other side of the equal sign. I'll go ahead and add that. Of the equal sign. That page is repeated. All right. And then another example is 3x minus 6 equals 6x minus x. So we're distributing the 3 to the x minus 6 first. So we get 3x minus 18 equals, and then we subtract x from 6x to get 5x. Subtract 3x from both sides. We want to get all the x's together. So then negative 18 equals 2x. Then we divide by 2 to get the x by itself. So x equals negative 9, and then I just flipped it so the x could be on the left side. So our solution set is x equals negative 9. So linear equations are in one variable, say x, and they are of the form ax plus b equals 0, with a and b in the reals, and a is not equal to 0. So solving a linear equation, we simplify. The first step is to simplify algebraic expressions on each side by removing group symbols and combining like terms. So in our example above, removing the grouping symbols would be like distributing 3 to the algebraic expression in the parenthesis. And then combining like terms is like by subtracting x from 6x. And then collecting variable terms you are trying to solve for on one side and all numbers and constants on the other side. So that was like when we moved 3x over. So like this, here's step 1. This is like step 2, step 3. This is step 2 as well. Step 3 is isolating the variable and solving. So that's like this step. And then we want to make sure to check our solution in the original equation by plugging in and making sure that it's logical. So here is our next example. So we're distributing the 2 to get rid of our grouping terms, and then we're also distributing the negative 3. So we get 2x minus 6 minus 17 equals 13 minus 3x minus 6. And then now we want to move like terms to whichever side that they need to be on. So we're going to be adding 3x to this side to get it with x. And then we're going to be adding 23 on this side in order to get it on the other side with the constants. So then we get 2x plus 3x equals 23 plus 7. We add the x's to get 5x equals 30, and then we get x equals 6. So we're going to check out our solution in the original equation. So when we plug it in, we end up getting negative 11 equals negative 11. So we're good to go. They equal each other. So solving for one variable in terms of others. So here we have the surface area formula of a rectangular box. So we want to actually solve for the variable w in terms of the variables, the other ones, such as length and height. So in order to solve for w by itself, we're going to treat the other variables, length and height, like numbers, basically, and not a variable. So first, we're going to group the terms. So I'm going to go ahead, since this term and this term have w, I'm going to group those with parentheses. That way, I'm able to subtract 2 length times height over with area. And then when I'm left with just 2 length times width plus 2 width times height on the right side, I'm actually able to factor out the w. So I go ahead and do that, factoring out the w, and then I get 2 length plus 2 height. And then I'm going to divide by that in order to get it on the left side. So once I divide by that, I get width equals area minus 2L over LH over 2L plus 2H. So that's our W. Okay, so solving rational equations. We're going to go ahead and solve 3 over x plus 6 plus 1 over x minus 2 equals 4 over x squared plus 4x minus 12. So we're going to go ahead and, just a quick side note here, think about what our domain here is. So I'm going to go ahead and factor the right side. So I have negative 12 over 4. So 6 times 2 equals 12, that I know can somehow add up to 4. Now I want a negative 12. So I could do 6 minus 2 equals 4, and then 6 times negative 2 equals negative 12. So this is going to be x plus 6, x minus 2. So that actually ends up being the same as the left side. So I'm going to go ahead and say that our domain is x cannot equal negative 6, x cannot equal 2, because that'll zero out the denominator. So in order to solve this, we're going to actually try to get rid of our rational expressions. So we can do that by actually multiplying both sides by the least common denominator. So in doing that, we're going to multiply those to both terms on the left side. See how I'm distributing it? And then that way we're going to be able to cancel out terms. So here I could cancel out the x plus 6, x plus 6. For the 1 over x minus 2, I could cancel out the x minus 2's. And then on the right side, I just have it multiplied. So I'm going to leave that there for now. So the left, we're left with 3 times x minus 2 plus x minus 6. And then the 4 is because we could cancel just everything that was in the denominator. So then I have 3x minus 6 plus x plus 6 equals 4. So we have 4x equals 4, so our x equals 1. And then make sure to check out that it works in the original expression. So I checked it out and plugged it in, and I got negative 4 over 7 equals negative 4 over 7, so it works. Make sure to try that on your own. So solving equations with a radical. So our goal is to isolate the radical here. So we're going to go ahead and move the 2 to the right. And then that cancels it. So then we're left with square root 2x minus 1 equals x minus 2. So we're going to go ahead and square the whole left side in order to get rid of the square root, and then square the right side. So we raise both sides to the nth power. We're left with 2x minus 1 equals, and then I multiplied out my x minus 2. I got x squared minus 4x plus 4. And then now I'm going to try and get all my x's together, and I'm actually going to set it equal to 0. So I'm going to add 1 to get it on the right. So I'm left with 2x equals x squared minus 4x plus 5. And I'm going to subtract 2x. And then I get x squared minus 6x plus 5 equals 0. I'm going to go ahead and factor that. And this is also a sneak peek to something later on in the lesson of solving for quadratic equation solutions. So in order to factor it, I do our x method with the 5 and negative 6. So I have 5 times 1 I know is somehow equal to 5, multiplied together to get 5, and then 5 plus 1 somehow equals negative or 6, sorry. So I'm going to go ahead and make negative 5 and negative 1, since two negatives multiplied together make a positive, and I know negative 5 plus negative 1 is negative 6. So we end up getting x equals 1 or x equals 5. So an important part of solving equations with radicals is to make sure our solution satisfies this statement. So we're going to check the solution in the original equation with x equals 1 or x equals 5. So on the left, I'm checking x equals 1. So when I plug it in, I get square root 2 times 1 minus 1 plus 2 maybe equals 1. I get square root 1 plus 2 maybe equals 1. 1 plus 2 maybe equals 1. And then I get 3 equals 1, which we know isn't a logical expression, and 3 does not equal 1, so that's false. And then we're going to check 5. So square root 2 times 5 minus 1 plus 2 equals 5. We get square root 9 plus 2 maybe equals 5. And then we get 5 equals 5, which we know is a true statement. Therefore, we can say that 1 is an extraneous solution. So our only solution in the solution set is actually x equals 5. Okay. We're going to practice rewriting an absolute value equation. So if c is a positive real number and u is an algebraic expression, then the absolute value of u equals c is equivalent to the u originally equaled c, or u originally equaled negative c. And the reason for that is because when we take the absolute value, we're taking the positive version of it. So if we had u was c positive, we know it still stays c. But if u was originally negative c, if u was originally negative c, we have negative c equals c. So we're going to go ahead and solve. 5 times the absolute value, 1 minus 4x minus 15 equals 0. So we're going to go ahead and try to isolate the absolute value, similar to what we did with radicals. So then we're going to move the 15 to the right side by subtracting it, or by adding it. So that cancels. We're left with 5 times 1 minus 4x equals 15. And then we're going to divide by 5 on both sides. And then we get 1 minus 4x equals 3. So here we could work with our definition of how to solve for an absolute value and split it up into 2 separate equations. So on the left side, we have when our u would equal c, and then on this side, we have when our u would equal negative c. So we solve for both. So on the left side, we get x equals negative 1/2. And on the right side, we get x equals 1. So take a moment to check that in the original equation and make sure that those check out. Alright, I'm going to go ahead and stop the video here, and we'll continue with lesson 1.5 in our next video with quadratic equations. See you then.